Hello, so this video is about RC circuit that we already talked about. So I want you to go to Cadence Capture, and we are going to open a new project. Okay, File, New Project. So let's call it RC circuit. Press OK. Create based upon an existing project, so we'll have our ground available. Okay, so the goal is to make an RC circuit and see how the voltage across the capacitor will change over time, and see what we learned about time constant. The time that it takes for the capacitor to charge is actually, we are going to simulate that and see it, see voltage versus time. Okay, so I need a battery, I need a capacitor, and I need a resistor. So it's an RC circuit. So I go to place, part, and I'm looking for a resistor, which can be found in analog library, and C can be found here as well. So I choose my capacitor and then escape to get rid of it, and then I need R. You can just type R here, it will come up. R, double click, put it here. Then you need then escape to get rid of this. Then we go to source to get my battery in place. So let's find VDC. Where is it? Here. Double click and put it here, connect it here, and escape to get rid of it. And I'm going to turn this, so right click and then click on it, and then right click and rotate. Great, then place, wire, and I'm going to wire this up. And to the ground. Okay, beautiful. So I have a voltage source which is 0 VDC. I don't want that. Let's put it 5 volts. Okay. And then I have 1K resistor with 1 nanofarad capacitor connected to 1 nanofarad capacitor with 1 nanofarad capacitance. Okay. So what I want to see is that if I connect a voltage probe here, how would the voltage across the capacitor changes over time? So you know that you will have like a shape that goes up. It's kind of exponential. It goes up, and then the voltage will be constant across the capacitor. So I want to see that. Oh, this is not connected, so. To make sure everything is connected, just press on V and run to see if you get 5 volts. So I don't get 5 volts. So what you should do is move it around, see everything is connected. Probably it's not, because I get errors. So when I get errors, that means these things are not connected. So I'm going to move them around. The way you do it, you just click on it. You see there's a space here. So I'm going to make sure they're connected. You should see a red dot. And then when I run it again, it should work. Yeah. So you have 5 volts here, 5 volts, 5 volts here, 0 volts here. But I want to see the voltage across the the capacitor over time is transient response, basically. So I put a probe here, and now I'm going to go to PSPICE, new simulation profile, name it RC transient, or trans, create. Okay. So runtime is the time that I want to see voltage versus time. I'm going to put 1 microsecond for now. I'll explain why. So I want to see from 0 to 1 microsecond, and you press OK. Another thing you want to do is that you have to put initial conditions for capacitor to make sure that its charge initially is 0. Because if you run this like this, let's put a voltage probe here. If you run this, you just get a line. You just get 5 volts. So you don't get the transient response because you have to tell PSPICE that my initial condition for capacitor, I want its charge to be 0 initially. So what you have to do is double click on it and go to IC, which stands for initial condition, and put it 0. This means that initially there is no charge on the capacitor and it's empty and it's getting charged. Therefore, its voltage will, yes, its voltage will increase gradually. Okay, now press on run. Okay, so as you see, the voltage, what does it show? It shows that the voltage across the capacitor will gradually go up until it gets to 5 volts. This 1 microsecond that I put here is, I calculated the RC value because 1K is 1000 ohm, 1 nanofarad is 10 power of minus 9 farad. So if you multiply 10 power of 3 ohms to 10 power of minus 9 farad, you get 10 power of minus 6 second, which is 1 microsecond. So this 1 microsecond is the RC value. So you get into 5 volts, as you know by now, is 5 times RC value. 5 times RC value, you get to the constant value, which is 5 volts. So I'm going to change this to 5 and then run it again. And you will see this beautiful graph that shows you that from 0 second to 5 microsecond, your voltage will increase gradually until it gets to 5 volts, and then it will stay at 5 volts. Okay, so this is the transient response of an RC circuit. You can see it on an oscilloscope as well, but here we just simulated.